Everybody, welcome on our next IntMeDA webinar. Today we welcome here our speakers, Pascal and Richard from ICAD. They will have a short introduction on themselves, but first of all I wanted to welcome them and thank them for joining us today. They will give us some insights on latest developments in MedTech AI and apply this to some of their existing products. Richard is an expert in medical imaging, artificial intelligence since almost 20 years, Richard?
Yes. Something
like that. And Pascal is in charge of the EMEA partnerships for ICAD. So he has very nice insights in the potential for artificial intelligence in our industry and partnerships such as medical device distribution companies. So welcome both of you, and I'll leave the stage to you guys.
Thank you, Olivier, for the invitation first. He forgot to mention how many years I'm in this business. So basically, few months with ICAD, many years in the medical industry. I used to be distributor manager for supersonic imaging in the ultrasound, and before worked for Philips, only located for Africa and the Middle East, and then before with HP as well for medical and ultrasound. So I joined ICAD back in April. Maybe I start with the presentation, with a formal presentation. So I'm going to share my screen. And so basically, I will start, and then I will hand over to Richard, who will take over for the more technical and focus on our solution in AI. I will share my screen. Do you see it?
Not yet.
Not yet.
I don't see it yet.
Don't see it yet. Is that better? Oh, it's okay. I know why.
There you go.
I just have to say okay. So now you see it probably.
Yes.
Yeah. So the idea we had was to go first with the basic of AI, give you a bit of insight what's going on in AI for MedTech and what are the trends. And Richard will take over to show you how we apply AI in a product called Profound AI for breast diagnostic. So when I started with, when I knew I was going to join ICAD, I just bought a book on artificial intelligence in medical imaging, because I would say, I had no clue basically. So I try to share with you what I learned about AI and what I feel actually on this market. So first, a bit of history. I was very surprised myself when I discovered that AI or artificial intelligence started a long time ago. Also, only recently we have heard a lot about AI in the press, in the news, sometimes with a lot of impressive info. And when we say it started in these 50s, and there is one event which has founded this science, but I would say science. And I remember when I was probably still in HP in '97, when Deep Blue made an impressive entry in this game by biting Kasparov on a chess game. So that was the first impressive event in this, or public event, I would say, in this industry. probably the 2012 was also something very impressive, a big event for AI, because this is the beginning of deep learning. And in 2015, you remember probably when Google using AlphaGo made a big impact when beating professional Go players. So I'm sure you remember this. Artificial intelligence has many applications, among healthcare, of course. But we live with artificial intelligence. Sometimes we don't. Sometimes we just don't know. But when we do shopping, when we travel, when we look at TV, we are facing artificial intelligence. Netflix does artificial intelligence. When Netflix recommends you, a series or movies based on what others looking at the same thing as you have seen, so they just assume you might like it. So it's really also artificial intelligence. Voice detection, writing, understanding. So all those are artificial intelligence, and always with the same benefit. Basically, artificial intelligence are expected to do less errors compared to human, because they are never tired, basically. It will help to take better decisions when you have a big amount of variable data to understand, to master. It's easier to master with an algorithm. As I said before, it can work 24/24, 7 days a week. It can handle complexity, and we can say that our world is getting more and more complex. As well, if we have an AI tool that can give us some support by doing some tasks that are not interesting, you can do better. It will optimize resources, and optimizing resources is one of the big idea of using AI in healthcare. By the shortness of doctors, radiologists, for example, in our field as ICAD, we know that there are less radiologists even in developed countries. So healthcare is one of the main areas of development. And in this field, there are many companies. ICAD is one, and I think in our field we are probably, but Richard has more history, but probably we have been one of the first to talk about artificial intelligence in a medical product, in a medical imaging product. But you have others, Zebra, Ecometrics, EDOC. There are many, not only in imaging, also in signal, in pathology, in management of hospital, in data management, in healthcare. There are many. There are some words, and I discovered these differences when I joined ICAD and I got the training from Richard. AI is an umbrella name. So AI refers to all the algorithms that try to mimic human intelligence. So it's a generic term. And under this term, you have two things mainly. So machine learning, so you see as an acronym ML, which is a subcategory of AI, and DL, deep learning, which is a subcategory of machine learning. And the difference with deep learning, for deep learning, is that it requires massive data. And you will see also in the rest of the presentations that I will talk about data several times, and Richard as well, because the data is this is the I don't know how to say in English, but this is the raw material. now, when you go to what is AI, we have to think that, especially for an image, because this is what we are working with in ICAD, but it might be the same with a speech recognition. What we see, what we perceive, is not what the computer will see. In fact, computer will see numbers, and you see already that the AI is mainly mathematics. So, as human, when we try to invent something, we try to see what is the closest in nature. So when we try to invent something, a machine to fly, we started to try to imitate the birds. And I must say that a plane has some similarity with bird. So when we came to when the science started, they start to mimic human brain, and at the basic element of human brain is a neuron. And in a human brain, we have about 100 billion neurons. And basically, the idea was, can we mimic neurons and then mimic human brain? And as you know, or maybe as you remember from your class, a neuron is made of different elements. One element is the axon, which is a cable. The cable that communicates the electrical pulse. And the neuron itself has elements which are connection, which was what is called dendrites. And those connections are connected to synapse. So each neuron has dendrites and synapse, might have thousands of synapses. So in 1943, that concept was put in terms of mathematics. And they have built, in theory, an artificial neurons which has input as X and has an output. And the neurons is basically a formula, is a mathematical function of the entry. And each entry can have a different weight. This is what is called in this diagram. And the artificial neurons can be converted in an algorithm with input, with a function, with an activation level in order to get an output which could be 0 or 1. And in theory, why not putting all those neurons together, connected together, in order to achieve a task? And this was already available as a technology in the 1990s, but in fact, it was not performing well. Computing power was not there, and it has been silent probably for 10 years or maybe 20 years. And it wake up in 2012 as performing better than traditional machine learning. So deep learning is the ultimate machine learning model actually. When we go back a little bit, one step back, just to describe what is machine learning, because this is also the gate to deep learning. So if we want to build a machine in order to identify pictures, is it a car, is it a bus, is it a motor or a truck? We can hardly believe that let's imagine that each picture is 400 pixels. 400 by 400 pixels. It makes a lot of pixels. We cannot imagine connecting each pixel to one neuron. So basically what we do, we try to simplify the image. We say, what are the characteristics of a car? So it has wheels, 4 wheels, a truck the same, a motor has 2 wheels. We can assess the size, 8 width, the ratio of size, the area of windows, and then we will simplify the image by some characteristics which are well identified to be characteristic of a car, a truck, a bus. And then we will build the machine still with neurons in order to classify the pictures. So this is machine learning. But the idea with deep learning is another thing. We will teach a machine to identify by itself images. So let me think I want to classify this image with a chicken. If I take the machine empty, it will just do mistakes. And this is not the result I want. So what we will do, we will propose to the machine a data set, a training data set with images of chicken and images that are not chicken. And this is what we call the training set. And when we build an AI algorithm with deep learning, we have training set, test set, validation set. There are many data type of data, but first training set. So again, I mean, we will train the machine. When it does mistake, we will adjust the machine. We will play with the neurons. We will adjust entry function of neurons, and then we will supervise the learning of the machine. And then it will hopefully it will correctly classify pictures. So in theory, we could connect each pixel to each neurons. Then a neuron will be connected to another neurons, and we will have what is called layers, hidden layers inside the algorithm. And each neuron be connected with the previous one. It might be today up to 100 layers. And then if you have a good detection, you will get a 1. If you have a wrong detection, you will get a 0. And somehow you get a function which is image recognition. So you already understood that the key for deep learning is data set. And the first company who has, let's say, built something which is probably public, it's Google with the ImageNet network. They have about 10,000 categories of image, cat, for example, cars, a bird, and it's open source. And each category has thousands of images. And when you combine this amount of data plus the computing power and the data science which has been developed, you get actually the capability to have very deep neural network to analyze images, and to classify, is that a car, a truck, a van, a bicycle, or in our case, is it a benign lesion? It is a cancer. So this is exactly what it is about AI. I mean, introduction to AI, I would say, in deep learning. Regarding the trend in AI, I mean, everywhere you go, you will see numbers which are impressive, growing. The market size, the number of companies being involved in this industry, the number of startups being in this industry. So it just, everywhere you go, it's growing. So it might look very much interesting for us being in this market to approach it. When you go more to the tool itself, and I realize that with iCAD, it has to integrate to an existing workflow. I mean, you cannot revolutionize healthcare and workflow overnight, so it has to integrate in the workflow. You have to go to regulatory. Sometimes it's not easy to get regulatory for software. I mean, regulatory bodies, they are used to validate product with a power cable, with the user interface, and it has to be accepted. It has to be accepted by the patient and by doctors. It has to demonstrate the performance, and you will see Richard will show you what we call a reader study. We have to demonstrate that the algorithm is as good or better than the physician himself. And we don't know exactly if patient will accept AI diagnosis. There are also some fear from doctors. I mean, I remember 2 or 3 years ago when AI started to enter in a big radiology show. Some radiologists said we're afraid that it might replace the work. And now they have understood that, I mean, those algorithms will be supporting them in the expertise, or will offer expertise in places where there is no expert. I mean, think about Africa, where you have remote place with no radiologists, for example. I mean, sending the images to a central plus where they have AI support or have access to AI will be much unwelcome. Today, what I see myself, because I mean, I CAD, probably I think I'm close to the reality, is that AI AI products works very well in a very specific and defined task. And in order not to take an example from ICAD, I went to something different, which is dermatology. And this was published in 2017. And in dermatology, it's quite very simple to classify disease. There are three main groups: malignant, benign, and neoplastic. And I don't know in your country, but in France, to get an appointment for a dermatologist is 6 months. 6 months. So if I could take a picture of my skin with my iPhone and get the service from an AI, I think I will go for it also. So basically, they have defined, classified lesions, skin lesion. They have built a neuronal network in order to classify those lesions, benign, malignant, and then they compare with a dermatologist. And what was probably not a surprise is that the CNN, the convolutional neuronal network, it's a specific type of neuronal network, perform as good or even better than a dermatologist himself. And then you get in some article, I mean, you get some very strong statement. Sometimes probably doctors don't like it very much, but this is what was published in Nature in 2017. I'm sorry, I'm getting to, yeah. And I have to go through the animation all the way. I'm going a little bit faster. There are several implementations technically. It can be, in terms of radiology, embedded into the PACS, inside the PACS of the hospital. It could be in the modality, I mean, it could be inside the machine itself that produces the data. It can be on the cloud for the given company. Can be on a marketplace like Apple Store, or it can be on a local server inside the department. In terms of business model, we see different things as well. Can be an investment, CapEx, can be an OpEx, operational investment, and actually it has few acronyms also. Could be, I mean, software as a service. It's like we have on Windows, basically. Could be infrastructure as a service. Could be, I mean, hardware included. for example. Or now we see also recently coming another acronym, which is, I would say, very similar. It's AI as a service. And in those cases, the customer will pay per use. I mean, it's up to the company to establish a rate. And each time, I mean, the customer calls for the application, you will pay for it. Or you can have tier. Let's say for us, you can imagine that a customer who will do 6,000 mammography per year, he will have a fixed cost, a fixed fee from 0 to 10,000. Then if we go more, we will get another tier, another price, and it will be flat by tier like that. So we know and we are sure that new business model will emerge in this. And I won't go through this in detail, but AI in healthcare has a lot of progress to do in terms of acceptation. Imaging is probably one of the, if you look at this graph, in the healthcare, imaging diagnosis is one of the main field of interest. And of course, breast imaging is also very much interesting. But here, they are available on many reports you may see on or articles you may see on the internet. And I have those documents if you are interested to get them. I'm going to the end. I'm coming from the ultrasound industry, and I remember AI appeared on the product roadmap last year, 2019, for the first time. I mean, and nobody knew exactly what was behind AI. And this July, a company I never heard about raised $53 million to develop an assisted AI, an AI to assist the doctors to scan, or the doctors or non-doctors to scan. So it could be a nurse, could be a doctor who have a GP doctor. I said, wow, expertise is moving from expert to non-expert. I think it's something on the way. So basically, it's and as I said here, it's there. And even, I mean, when you look at the future for AI, it's very strange. I mean, this is an AI algorithm which is open by Google. You decide in one entry, you enter a style of picture, and the algorithm will detect the style of that frame. And then you enter on the other side any picture, so it's my picture, and then the neural network will reconstruct your picture based on the characteristic of the first frame. Could be Van Gogh. I could have put a frame from Van Gogh, and I could have got my picture as Van Gogh could have painted. And I want to leave enough time to reach out to move more technically. Are you okay moving to Richard and then go for questions?
Sounds great.
Thank you.
Okay.
Yeah.
Thanks. I like the picture.
Yeah.
Let me know when you can see.
I stopped my share.
Screen. I have to hit share, I guess. So do you see? I have a bunch of things on my. Okay, so do you see my screen here? Hi, everybody. My name is Rich. I'm coming to you live from Helsinki, Finland, even though I'm from New Jersey in the US. So if I go too fast, just stop me, because sometimes my New Jersey makes me go a little quick sometimes. So if I see anything that we've already covered, then I'll go through it and get on to other slides. But I have a few things I want to show you leading up. And one thing about what's going on with AI, and especially in radiology, is there is a big real thing called burnout for radiologists. And there's been articles on this for a few years now. And this one here was written by Jeff Hoffmeister, who is ICAD's medical director and one of our vice presidents and one of the founding members of the company. from back in the 90s, actually. So we've been around for some time. I haven't been around quite that long. It was alluded to that I've been around for about 20 years, but I started with iCAD in 2002 before it was called iCAD, just so you know. So, but it's a real thing about burnout and helping radiologists and anybody get through their workload because of just the sheer amount of the technology that needs to be used and images that need to be interpreted. So there are pros and cons, and as you talk to customers, if you talk to anyone with any product that you represent about AI, there's definite pros, like we mentioned before, about helping to do whatever anybody can do, just do it better and do it 24/7 without getting tired, and have efficiency and have a second opinion and even a first opinion, as deep learning allows us to get so much better in what we do. But there's definitely cons, which are the implementation and having other systems be valid to show your information as results, for example. Like we need, as iCAD, we need to be compatible with the mammography systems, number one, and we have to make the software work with each individual system because they're all different about themselves and the way the images look. But the different PACS and reading workstations that the doctors used to look at the breast images, they have to be able to show our results in there. So we work very closely with both sides to be as compatible as we can across the board. But some is putting the cart before the horse, which is a saying that we use a lot, is you can have the technology, which would be in the cart, but you have to have the way to pull the cart. So, you know, where's the horse? Is it in front or behind the cart? We need to have the technology, working with the hardware that's available, working with other systems, all to be able to work together. And there is the question about job security, but here's just another thing. There's real articles out there for a few years now. I mean, this is a heck of a thing. Back in 2015, before tomosynthesis, which is 3D mammography, which is now one of the biggest things for radiology and mammography, it gives hundreds of more images for each patient that the doctor has to interpret. A doctor used to read and interpret 4 images for a woman's mammography, and now it could be 600 images they might have to look at. So this is back in 2015, before this technology was really taking off, so it's only even worse now. But a lot of it has to do with perception. That's what the AI does, is it helps get around the human part, the human condition of being tired and multitasking, but also our perception. So if you look straight at this image here, you may see some dots kind of flickering around in front of you. And I use this to train radiologists because, of course, radiologists and we think we only see what's in front of us, even though sometimes when we're tired, our eyes may play tricks on us. It happens to radiologists too, because they're people as well. But in fact, you might see some gray or black dots kind of flicking around in the white areas. And I don't want to keep it there too much because it could cause headaches, but in fact, there are only white dots. This is a static image and the shades are playing tricks on us. And does this happen in the gray, white, black images of radiology? It may, but it's just to show that our eyes aren't perfect for the job that we think they should be doing. And it's all perception. So this is a fun one that the radiologists like when I show them this. There are faces that are in the nature picture here. There's a US artist who made this. Her name is Bev Doolittle. And this is not a case of pareidolia. Now, pareidolia is that thing where, like, you look at a cloud and it looks like a fish, or it looks like Mickey Mouse or something, or you look at wood grain on the floor and all of a sudden you see a face looking at you. Somebody on purpose put faces in here. So when I show this to radiologists, they could usually find 6, 7, maybe 8 faces. Well, I'm not saying they're very attractive faces, faces inside nature here, but they're hiding in here. So there's actually 14, and nobody finds 14. So I went to one of the biggest AI things ever, Google, and I found where the answers were, and I drew my own boxes around where the faces are hiding inside here. So this is the kind of thing that we do within our Profound AI product. And our older product called Second Look for mammography, to find the things that are right in front of us that might be that thing that we're looking for. Now, we see faces here. Again, they're not exactly the most attractive looking faces, but who am I to, comment on that? But there's also horses that have faces. There's the person on the horse that have faces, but that's not what we were looking for. In this case, if the face was cancer, that's what we'd be looking for. And there could be something that looks a lot like cancer that we don't want to guide the doctor to, and that could be the horse's face. That's the kind of thing that we do within Profound AI. And this is just another depiction of the different levels of machine learning, artificial intelligence. The thing that's pretty funny to me is AI is the catchphrase now. If it's AI, people are very interested. 20 years ago, it was still AI, but they didn't call it that really. They called it machine learning. Maybe if we called it ML back then, maybe it would have taken off more. But we've come full circle to beginning with the name of AI, going to machine learning, and then going back to AI to say that it's deep learning. So now AI is synonymous with deep learning, and that's pretty much what the market thinks of. But what did it do? Back with machine learning, it had limits. You can only write software by hand, which was with codes and programmers who are PhDs and masters of science. They write the code to say, in a computer code, here's what I'm looking for. But it could only be so good. And no matter how much information you put in it, it gets to a level where it plateaus, where you can find so much of something, but there's still a lot of false marks, and you just can't make it any better, no matter how much data you feed it. So pretty much everything stopped in my market back in 2012 up until about 2016, because deep learning didn't exist in the field. It just didn't exist for a few reasons. One was there wasn't the hardware in order to support it, but the ideas were there. So Einstein, he said, once we accept our limits, we can go beyond them. So we had to accept that the machine learning just didn't do it and move on to AI, where we can give so much information with the new processors like graphic processing units and things like this that allow us to have millions of little thought processors inside a computer in order to give us much more specific information. And I think it's pretty interesting that AI kind of looks like the name Al to me, so I liked it side by side. But here's a graph of old software, for instance, for anything that was machine learning versus what deep learning can do. Deep learning, we just keep feeding in information and we don't know where it stops. The logical end for deep learning being as good as it can be is being better than a person and finding or doing the job 100% great without any mistakes. We don't know if another technology will come along to beat this, but at the moment we know deep learning is the thing that allows us to be the most sensitive and the most specific at the same time. And the older algorithms just couldn't support that. So I'm going to run a video here to show you what our AI product does in action, and I'll try to keep up with it as it goes if I can find where it starts here. So I'll just describe what happens. First, the doctor looks at the older 2D images of the patient. Then it will go to the tomosynthesis images, which in each area there could be 50, 60, 80, 90 images in the one area. And we will have our AI toggled on already to guide the doctor to go look immediately where we believe is a cancer area. So as it goes through here, we already see over here that there's an area the doctor should look at. And the doctors scroll through the images faster than what I'm doing here. They go really fast up and down. And we can change the sensitivity. We could say, hey, I want to see some more things. At the top, we're saying we're 97% confident that that particular area over here, I just stopped it, we're 97% confident that that area is a region of that has cancer in it. And it's on image number 33, and there's 50 some odd images in there. So that's the kind of thing that we can do. And what we do is we have the doctor have this technology turned on already the first time they look at the case. It used to be so that when they used the older machine learning kind, they would make their reading, then they would turn on what was called CAD, computer aided detection, and say, okay, did I miss anything? You know, is there anything here that I should look at? Now we have it so targeted, so specific, with so few false findings, we could say, look there right now, because we know pretty much something's happening there. I'm just going to turn that back on so it finishes. They have to go through however many images they have for each of the breasts. But we have each finding will have a score next to it. The lower the number, the more chance that it's not cancer. However, it still can be cancer. The doctor always decides that. Again, we're not taking the doctor job away from them. We want them to be better at what they do. We want to make a better radiologist, in fact. So on top of just that area where we believe there might be cancer. There's another thing called a case score, which is hiding down here, and it says case score. And this is an assessment of right now, the confidence we have cancer is in there right now. So it's kind of an immediate risk. And we're saying we're 99% sure that this particular case has cancer in it. And the idea is we're analyzing everything that we find throughout the case, comparing it to normal and cancer cases within our database. And this is how we decide, hey, doctor, we want you to do something about that. So DBT is a name for digital breast tomosynthesis, if you haven't heard it before. So again, there's very many images, and we analyze every image. And that's a way that we get very specific, because the same thing that might be cancer, you actually see in different levels because it has some depth to it. So we're more specific at finding it because we see the same thing a few times. Now, this is a very interesting slide. This is samples from our database. On the left side of your screen, these are actual areas that are malignant that the doctor has to say, they look inside the breast, they say, oh yeah, I think I want to do something about this, which really means stick a needle in it, take out some cells, have it analyzed, and say it's cancer. On the right side, these things are not cancer. So they look very much the same, and in fact, they look exactly the same. And it's very difficult for the doctor to decide to do something with this or not. And we have to train the computer to be so good to not put some kind of a circle around things like this on the right side of your screen, or at least give it a low value compared to the ones on the left side of your screen. So the doctors for radiology and mammography, they have a hard job to discern things like this. And we have over 4 million images within our database to help them do that. So I already described that one score, which was 97%, saying we're very confident something was cancer. And we have the case score, like I said, which is like an immediate risk. And this is how we decide to give a score to a particular region. Using the AI, there's different databases inside the software, and any finding that we see that looks anything like cancer, for instance, one that would have a 70 some odd percent, it could be 71, 72%. If it looks like cancer 70% of the time compared to those things that are not cancer 30% of the time, that's how we give the score. And it's up for the doctor to decide that. So we also have the same technology available for the standard 2D mammography, which is the prevalent way to do mammography outside of the US. The US is moving very much fast towards tomosynthesis, which is the 3D, and most of the world is still doing 2D, although there's some areas in Europe, especially private customers, radiology practices that are using the 3D one. So we have the same technology where we can give the scoring, that kind of a thing, for the 2D. And this is just an example of why they're using the 3D. Here's a 2D image, just a regular 2D image, and it's very difficult to tell anything in here because there's all this white stuff that's normal and things like this. But inside, on image number 20 of the same patient, this area right here is really cancer. So the technology of the 3D is really good, but then you need help to get through it, and that's where we come in. So we did a reader study, and it was in journals, and I know this one back and front, but we had 24 radiologists read a bunch of cases that had cancer in or did not have cancer in it. And it was a very difficult data set because there were 65 true cancers, but there were also 65 of those ones that look a heck of a lot like cancer that weren't cancer that they had to weed through. So we wanted to see how did the doctors perform, and we had very good idea that we'd help them find everything faster because of this way to navigate. And also what we wanted to do was find more cancer, but also have them not do work on things that were not cancer. And this is exactly what we found. For this data set, 24 radiologists found about 8% more cancer, which is huge. They had fewer callbacks of 7%, and they read better than double fast, 53% faster. So what happened was, it's the first time any product ever had these same things, all three at the same time. Find more, be more specific, and go faster. So, and at the time, that was our software that was not released yet. And now our software is even better than what that was. They were operating with software that could find about 91% of the cancer. Now we have 94% and up to 97% because we have those different operating points. Here's the effect. There were 24 doctors. So this is pretty dramatic here. So our operating point was about 91% finding cancer. And these are the 24 doctors, and the circle size indicates time. The biggest circle is about 2 minutes. In the smallest circle, some doctors were going extremely fast. Some doctors should have stayed home because this doctor found like 38% of the cancer, which is terrible. But they were going very fast. The smallest is about 25 seconds, which is crazy fast. But the idea is if we're successful, we can make this happen. If we're successful, we can have the doctors move up, which is find more cancer, have smaller circles, which means go faster, and move over to the left of this diagram because that means they had fewer false findings. So this is the effect we had on 24 different radiologists, and this is what we really hang our hat on when we're talking about this particular product. So we got them to find more, not work up things that weren't cancer, and to go faster. And these are the 24 radiologists. Individual times, some went from 70 seconds down to 15 seconds, and even going so fast, they still found more, which is crazy, but that's what we were able to do. And this is the stats on what we were finding at release. We were finding 91% of the cancer, with about 60% of the cases not having any marks on them at all. With all those data, no at all. And now we're 94%. So this is everything that digital breast tomosynthesis can do, the 3D, and then add on top of that the AI, it's even better, it's even more cost effective. So that's all the information I really have for you, other than I can show you, I'll show you one case from the reader study, and then we can have questions. This is a real case from the study itself, and there were findings of 68% in this particular area, and on the other view of the same breast, there were other findings with lower values, but the software was 85% sure there was cancer in here. So without using our product, the doctors took an average time of 110 seconds to read the case, and only 12 out of 24 doctors found the cancer. Using it, they went just over a minute, but 22 of the doctors out of 24 decided that yes, that was really cancer. And that's the kind of power we can bring to help the doctors go faster, be more specific, find the cancer. So that's really all the information I have about this, and definitely we can take questions as you like.
Thank you, Richard. Thanks for your presentation. Yeah, with this last example, we can already summarize. I think we're all aware that AI can and will improve clinical effectiveness. If you see the number of readers which found the cancer with the AI versus the ones who didn't find it without the AI. I think with deep learning, we notice that there is a difference between real AI, the deep learning AI, and pretended AI, because it's a hot topic. So everybody talks about AI, but what is AI and what is real AI? In MedTech, that's kind of important. Yeah, I think maybe there are several questions, but I think for us as distribution companies, the biggest question is how should companies like ours adapt to this new trend? How can we implement this? Which business models are related to it? So that's I think a big challenge. We personally, as RMS Medical Devices, among others, we work with this ICAT solutions, which is impressive. But we also noticed that even though we weren't in software solutions or medical software solutions since 2 years ago or before 2 years ago, now we see that it is a real trend, and questions also come for AI solutions in other disciplines or clinical specializations we work in, such as GI or urology. So that's I think it's an interesting topic to follow up and to learn more on. So if anybody else has something to add or questions to add, feel free.
Gentlemen, Yuri Pavlicek speaking. There was great presentations. Really appreciate stuff which you and practicality in terms of the business case with the ICAT already on the table. So really appreciate and you know, this is exactly the kind of the topics we like to share among the members and associates, so that we advance medical treatment in our relevant markets. So again, big thank you, and would love to ask you if you can share with us the presentation, so we can share it with the members who were not able to participate on the call today.
Yeah.
I think that's okay, for sure. So should we give to Olivier to disperse the information?
That would be great.
Christophe, I think Christophe is in our email loop, so you can.
Okay.
Thank you.
Okay.
Are there any other questions or more targeted questions from some of the attendees?
Yes, Olivier, this is Pascal. Thank you for the presentation. The question is, ICAD today is in cooperation. You promote your system directly, or do you combine it with some other technology and with other companies? How do you proceed today to positioning your AI technology on the market?
We as a distribution company or ICAD as a manufacturer?
Okay, ICAD is a manufacturer mainly. They don't distribute. Okay, okay. Because the thing is that what I see is a big interest, for example, in cancer detection at early stage. To answer to your question, Olivier, I think this is definitely now, and I would say for me that makes sense. What I see in cancer treatment, first of all, in distribution, what I see, it's two lines. One is depends on the distribution is a tool or commodity business, and then AI can be beneficial for logistic or to improve some things. And then on the other side, you have the treatment. And when you distribute technology for treatment, for cancer treatment, for example, or for cardiology, or this type of thing, or interventional radiology, then immediately these come up. Means that, for example, to positioning a radiofrequency or microwave ablation needle into the tumor, AI will be definitely helpful, because today we are working with potential robots to positioning the needle. But for me, that makes sense that AI will also combine with the robotic in order to positioning in the best way the needle. The technology works to treat the tumor, but positioning, it's like a GPS. If you are not able to well positioning your device, then the treatment will not be accurate at 100%. So that's definitely some things which I see as a great improvement. The question is how can we combine that with some other technologies? Because I see a combined things and not only using it as a software. I see if you see my point.
I can understand, and to make it clear, RMS is a local partner in Benelux for ICAD. ICAD has 2 channels. They have in some countries, mainly also in the US, but also in France, a direct sales network. They have OEM networks. Correct me if I'm wrong, Pascal, because that's more your business, but they are developing software for big mammography vendors. But for us, for me, as a distribution company, ICAD was an interesting tool, and other AI solutions are an interesting platforms because it's linked to some of our diagnostic products, such as, for example, Richard, I think mentioned this. If they see something, they're gonna stuck a needle in it to confirm the diagnostic value and the pathological value of yes or no cancer. And we are in the consumable business, biopsy needles, mammotome, vacuum-assisted biopsies, but also the treatment aspect. We also have the surgical gamma detection probes, which the surgeon used to detect the confirmed lesion and to excision the lesion. Now, in between, we thought AI, ICAD in this case, was interesting because we were already in the breast cancer detection in terms of pathological value, breast cancer treatment with our gamma detection system, but in between we found it interesting to jump on this car, even though we weren't in software, jump on this car to offer a software platform which is linked to breast cancer. So for us, that was a big step, a challenge, but it was less complex, or also the sales process linked to this. It's another sales process for consumables, biopsy needles, stents, catheters, than for software solutions. But actually, everything is linked, and it goes very smoothly, and I think it's pretty easy to integrate in your sales procedures, sales process, and operational procedures to add this to your portfolio, even though you're not a real software company. What is your experience on this, Pascal? Because he can tell us more about this on an international level. I'm pretty sure you have partners which are in the medical software business, but also partners like us.
What I see for today, for example, I will organize tomorrow a French webinar focused with two KOL, one from Institut Gustave Roussy, the other one from La Timone in Marseille, and the two others from Lyon, in order to talk about these microwave ablation and the good result in the liver and the lung tumor. What we see, and that's what we made with Dr. Thierry Debert in Institut Gustave Roussy, is that he used the microwave system with the current development of robots in order to positioning the needle. This company is Quantum. Quantum is a company founded by Bertin Naum. Bertin Naum is the ex-guy from the robot, which from Rosa robot, which has been sold to Zimmer Biomet a few years ago. I know Bertin because I used to work with him at Computer Motion when I started in '99 in robotic. What I see is that there is a navigation system, but the software excites me a lot, because what I see is the possibility to combine with the imaging. And what I see is that interventional radiologists, they continuously read the pictures in order to optimize the positioning of the needle. And from my point of view, I would be delighted to continue the conversation with Pascal and sorry, I don't see your first name.
Richard.
Okay, because I see a real potential for that. I see a real potential, but I'm looking for something simple to use, which I call plug and play, because the key to be successful in this type of things is to make it easy to use for the end user, which is in my range, the interventional radiologist or the surgeon. Because when it's too complicated, then it makes people to be to step away from that. But I see a real potential in the breast for sure, definitely. But I see in the liver or in lung or in kidney or in pancreas as well, because positioning needles in this type of space is not easy to do. And we're always looking for confirmation of stuff like that. There is also potential, and I know that Professor Cusno in Paris Internal Hospital is working on different superposition, overlapping of pictures and imaging in order to optimize his positioning in the prostate. But these type of software, sorry, would be a need and would be a must for me in my current business, definitely. So
what we did notice is that we hired specific people for this new portfolio. So we did hire medical imaging technologists or people with a relevant background in PACS, RIS systems. So because even though it's a plug and play system on the front end, in the back end, there's a lot of things which are important. The radiologist or the end user, he doesn't have to be aware of it, but we have to make sure that everything is well integrated, that everything is 100% functional, and we make it look very easy, but actually in the background, I think Richard and Pascal Dardin can confirm, there's a lot of parameters which you should take into account. And then also the application training is important. Make sure it's the same with a stent, in my opinion, as with an AI platform for a radiologist or for a surgeon or whatever. It's never the doctor's fault if something doesn't work. So we have to make sure that they're well trained, that they use the tools, whether it's a stent or an AI platform, that they know how to use it and that it performs like it should perform based on their input and their usage. So that's, I think, where also a medical device distribution company can play a big role, because as AI picks up, it's a hot topic, it's a trend. It's a pretty easy sell if there are budgets. So I think big vendors, they attach it to their platform and AI will sell. But they will never have the same support, local support, training, education, application training for the end user, because it's not their focus. And for a medical device distribution company, a local player, they will focus on application training. They will focus on full integration and make sure everything's functional. So that's something I noticed. I don't know, Pascal Darlin, what's your experience or meaning of it?
For what I see, I mean, when as a supplier, as a manufacturer, our goal is to touch as many customers we can. And in our ecosystem for iCAD, so we are an accessory somehow, which is inside the inserted in the imaging chain between the mammograph, which is a modality producing the data, and the PACS companies who display the data we have computed. So for us, the idea was to integrate ecosystem. So first, I mean, iCAD was very close to mammo manufacturers, GE, Philips at that time, Siemens, Fuji. And then the PACS people started to get interested in AI. So we are building also relation with the PACS companies. But at the end, you always need to convince the end user. You need to talk with a physical person, which is a radiologist, in order to get attracted by our software, our solution, and to use it at the end. And I know that some AI companies went or are going to marketplaces, places where each user can just download or use the application. I'm very skeptical because I mean what we sell, it's medical product, so there is training needed, upgrade, update, clinical support as well, and at the end we need physical people on the ground in the hospital to teach, to promote, to highlight benefits, because still, I mean, there are competition outside. So as a supplier, we need to have salespeople, distributors, way to touch the final user. And it's an ecosystem, and up to you with your own portfolio of products to identify your ecosystem and which AI tool product may fit in your ecosystem. If your ecosystem is robotic surgery, interventional radiology, there are AI tools, even if they are, let's say, with hardware or without hardware, integrated or not integrated. There are ways to sell either as a CapEx, as a capital equipment, one shot, or as a hardware, I mean, as an OpEx operational investment. But it's growing market. I mean, I'm sure it's a big part of the future of healthcare business.
Pascal, can I just ask you a question?
Yeah.
You speak about the ecosystem, and if we look at it and we speak about the radiologist, which will be the end users, but I'm thinking from the point of the patient and what we see now where patients, they're just searching for knowledge wherever they can find, that how we actually can support the entire ecosystem. So you go and you say, okay, we look at it from a patient-centric point of view, and all the people that they actually interfere with in the process of the AI, which is going to be the future.
Wow, it's a tough question, in fact, because today I'm not sure patient. So I'm sure as an individual, I trust AI. And when I go into my car, I switch on Waze, and I trust Waze to find my way. I trust Netflix to propose me good series or good movie that it prevents me to search. But in healthcare, I'm not sure the patients are ready to trust or to hear about AI. I mean, they trust the doctors. I mean, they trust the person. And we have some doctors, especially in UK. I don't know why in UK, but they are very afraid of being suited. How do you say a tribunal to get to a
lawsuit?
A lawsuit. I mean, they are afraid of that because they say if the AI is putting on the report the probability of cancer is high, and at the end the cancer was not detected by the doctor, it might be in a situation where doctors will be very much uncomfortable. And actually, I mean, we provide the information to the radiologist, but that information today does not go to the end user, which is a patient.
But the classification, is that a 2A?
Basically, we give a value which is the probability of cancer.
Yes.
Not
according to virus,
classification.
No,
so it's not a medical device classification.
It is, but it's in what we call the Richard help me.
It's the class 2.
The class 2.
Yeah.
Yeah, 2A, like you said.
Yeah, 2A, exactly.
Yeah,
so, and what is going to happen now with the MDR is that that you will have all the post-market surveillance, and there will be much more where you actually will have the interactions with the patients as well. So there will be a lot of knowledge that actually will come to the surface, so that we actually look at it and say, okay, instead of it suddenly it hits us, that you actually find a way how to develop the ecosystem, so you know how to safely maneuver the journey, as I see it.
Yeah, there's more to the ecosystem, like you said, which is a good word there, because one of the focuses that we have is to get away from age-based, population-based screening and get to more personalized screening. So we just got CE mark for a risk product, which is a 2-year risk product, which is now available along with our detection. So what we do is we have it's called Panorama, which is we can see. Pretty soon we'll be able to read the prior images coming over from the PACS or storage, use that data to help us, like the doctor is helped by prior images with the current view, and then also use the risk to see, does the patient, should they come back sooner than the 2 years or 3 year screening protocol, because we're highly confident that something's going to happen inside before the next screening. So we want to make it more of a patient focused, get away from this broad screening, because everybody's different actually. This is one of the pushes by our company.
And also, I think here, as we're here speaking in terms of the IntMeDA, we're all medical device distribution companies or related to medical device distribution. I think that's also where our role becomes important in MedTech AI, because Pascal Darlin correctly mentioned that, yeah, within the next couple of years, probably there will be kind of an app store or an AI platform where you can just download your apps. But what's then the value if you're not trained on how to use this AI, on how to communicate this kind of new information you receive through AI to your patients or to the other physicians involved in both the diagnostic and treatment process of this patient? So that's where MedTech distribution companies specialized within their domain, they are able to communicate with their users, doctors, nurses, whoever, depending on the AI you use, and make sure that they use it in a proper way, and that they use not only the AI, but the information coming from this AI in a good way to improve medicine in general. Just my opinion, by the way.
This is perfectly right, Olivier. Perfectly right. And
Okay.
doctors, yeah, it's okay. It was a side comment.
Olivier, thank you very much for bringing Richard and Pascal to the meeting today. It was a fabulous introduction to the AI and very practical. Thanks for all the members who joined the call today. Again, very instrumental, and very happy to say that we've got our new member joining us today, Marcelo Angular from Buenos Aires, Argentina. Marcelo, if you're still on the line, could you just introduce yourself briefly?
Yes, can you hear me?
Yes, we can.
Okay, well, it's a pleasure to be in front of you for the first time. Just to break, briefly to break the ice, you know, we all have 2 ears and just one mouth, so there's very much for me to hear and learn the first time I enter this group. My name is Marcelo Aguilar, as you have just said. I've been working for the medical devices industry for the last 20 years. Many kind of medical devices are part of my regular business developing, and I've been working for the Americas for the last 10 years, and is occasionally taking part in some particular business in the north of Africa and in some countries of Europe, like Germany and Belgium, and in some parts of Asia, like Indonesia, Malaysia, or Arabia. Well, developing distributors in all these countries. One of the countries I started working with medical devices for was Abbott Laboratories with the infusion pumps. And after that, I used to work as a sales director for the Americas for an Argentinian company dedicated to producing medical ventilators. The name of this company is TechMe. TechMe opened up facilities in Atlanta, Georgia, south of the United States, some years ago, and I opened up the first distributor for this company there. After that, I took part of Draga, Argentina. After that, IntMeDA, that's an Argentinian distributor, a medical devices distributor company. And nowadays, I'm part of ADECOM. ADECOM is a company dedicated to gas systems and medical compressors. My responsibility nowadays is as a sales director for the Americas. Well, here I am. I think there's much added. I have very solid value to add to this group, learn from the group, and take part with with information and with my point of view. And well, here I'm available for all of you. And first of all, very grateful to be received by you. And I congratulate you, first of all, because you have an ambassador there called Christoph Jelinek, who has received me, and he's been very kind to me. So thank you all for giving me this part of the time to take part.
Thank you, Marcelo, and welcome. Thank
you.
Gentlemen, before we disembark, just a kind of reminder, we will hold another call in about a month's time from now. Please share with Christoph, Olivier, or myself your topics you would like to cover. We're hearing and seeing many requests specifically regarding COVID testing, new technologies coming up and vaccination and all that stuff. So this might be one practical topic to get prepared on. And anything which you see would be valid to discuss, please share it with us. I don't know how you see it from your side, from Aspironics, where we cover Czech, Slovak, and Poland market. What we've seen, especially in the last, I would say, 2 to 3 months of COVID live, that actually we are getting literally like daily offers from global companies to distribute them in our region. I presume it's actually driven by twofold. Many business development and channel partner managers are sitting on the computers and screening their websites and LinkedIn's. Though the second one, which I feel is strategically more important, that we already see a number of the big corporations pulling back and reshaping their cost structures, which might be actually, again, to the benefit of distributors as companies as we do represent on the call for the future. So if you see similar trends, don't hesitate, share the news, updates. You got the emails, phone numbers, WhatsApp groups. And again, be well, healthy. And Olivier, once again, thank you for leading this call today.
Thank you.
Have a great afternoon, everybody.
Thank you. Bye-bye.
Thank you
Thank you very much for your time.
Bye-bye.
Thank you. Bye-bye.
Bye.